Acid and base is day 7. Aim. How do we use table T to determine titration, neutralization reactions? Table T, as you know, is where all the formulas are located. So let's proceed over here. From yesterday's notes, we learned that H in the front, just like in the rest of all the other day's notes, in the front means an acid, so HF is an acid plus a metal with the OH is a base. What we learned? Acid and base equals salt and water. So we're going to split up the compound. Positive, negative, positive, negative. Positive goes into negative. So salt and water. So HOH or H2O, you can leave it either way, by the way. It doesn't matter. Okay? Now you have over here, again, positive with the negative. Li with F. By the way, if you look at the charge, Li is +1, F is -1. So what do they do together? Just cancel out. And that's your answer there. Salt and water. Okay. Double replacement reaction. The next problem is a reaction between a metal, Ca is a metal, right? And H2CO3 is an acid. Well, we learned at single replacement reaction, when you combine a metal with an acid, you're always releasing which gas? Well, hydrogen gas. Positive, negative, so you have CaCO3. Well, if you look at the charges, Ca is +2. CO3 on table E is -2. So what do they do to each other? Yes, they cancel out. Plus H2. Okay, let's move on. This is something you can look up on your own time. It's shown the lab that we should have done, which is called acid-base titration. Okay? Let's move on. No. Back. Let's go. Oh, here we go. All right. So here's a formula, guys. It's on table T. Titration. Titration or neutralization, right? To neutralize or to titrate is basically, if you have an acid, you're going to add a base to neutralize it. Because you remember, going back to the pH scale, neutral solutions, what number? Well, below 7 is an acid. Above 7 is a base. 7 is salt and water. Salt and water is pH neutral. Salt and water. Okay? So here, look what it says here. Neutralize or titrate on a reaction means equal sign. So let's look at some of the things that for a titration reaction. Here's a formula. Ma, molarity of the acid, RH plus times Va, volume of the acid, equals molarity Mb, molarity of OH negative, times volume of the base. So again, this formula's on table T. Let's look at the formula here. Actually, look at the question. How many milliliters of a 0.3 molar HCl? So 0.3 molar HCl, well, HCl, is that acid or a base with the H in front? Well, that's the acid. So this number is your molarity of the acid. It says how many milliliters? Well, do we know the volume? No. So 0.3 goes there. All right. This is X. I need to neutralize 10 milliliters of a 0.5 KOH. Well, these two go together, right? 10 of a 0.5. and KOH is a base. So 10 milliliters is the volume of the base. 0.5 molar, right? 10 of a 0.5. KOH is the molarity of the base. So let's clean this up. We have 0.3 times X equals 0.5 times X. I'm sorry, 0.5 times 10. So 0.3 times X is 0.3. X equals, well, 0.5 times 10 is 5. Divide them both by 0.3. So let's take our calculator. What is 5 divided by, let's say, 5 divided by 0.3. Yes, X equals 16.67 milliliters. Any questions there? No. All right, let's continue. Now, let's do some more problems, practice problems here, okay? Again, here's our formula up here. It was right there. Where all formulas located in table T. Now, how is this question going to be a little different? Well, first of all, it says if 30 milliliters of a 3 molar CaOH2. So 30 of that, so you know these two numbers go together on the same side, right? Solution is titrated. Remember we said before, we see the word titrate or neutralize, that is an equal sign. So let's put an equal sign above that. That tells me that the first set of numbers on one side is the equal sign. The next set of numbers are on the other side. What is the molarity of 10 milliliters of H3PO4? Well, 10 milliliters H3. H3 is an acid, right? That's on the other side. So let's write out the equation. MaVa equals Mb and Vb. Okay. Again, 30 milliliters of a 3 molar CaOH2. A metal with the OH is a what? Yes, a base. So 30 milliliters is our volume. 3 molar is our molarity. OH2 goes there. Why? Well, look at the question. Look at the formula up here, guys. Volume of, the molarity of the base. Okay, so there'll be molarities, OH ions. Guys, how many OH ions are here? That's right, OH2. So that means we're going to multiply it side by 2. The other question, we did not have to do that. The other question had, if I was not mistaken, KOH or NaOH. There's only one OH. This time there's 2, so that's why we have to multiply this side by 2. Now, let's look at the other side. What is the molarity of 10 milliliters of a H3PO4 solution? Okay, H3PO4, that is your acid. Okay, so that's equal. Goes to the other side. 10 milliliters of the acid goes here. It says, what is the molarity? Well, we don't know. That's going to be our X. But it says here, how many H's, guys? Go back up to the formula. Ma, molarity of H plus. How many hydrogen ions are here now? 3. That means we must multiply this side by 3 ions. Again, the other question had, I think if I remember, HCl. HCl, guys, is 1 hydrogen, so you don't need to multiply the side. Okay, so let's move on. 3 times 10 is 30, so you have 30x equals 3 times 30 is 90, times 2 is 180. So you have 30, so you divide by 30. 30x equals 180. Divide by 30. X equals 6 molar solution of H3PO4. I know, my handwriting's terrible, I know. All right, any questions there? Okay, always make sure you send me a reminder if you have a question. Let's do the next one here, okay? So I'm going to discard everything here. Here we go. Question here says, how many milliliters of a 4 molar H2SO4? Again, guys, hydrogen in front, acid or base. It's an acid. So let's write out the formula again. All right? MAVA. MBVB. Okay. So it says 4 molar H2SO4. Well, that's how molarity of the acid is 4. How many hydrogen ions are here, people? H2. So multiply it side by 2. It says how many milliliters? Do we know? No. That's X. Need to neutralize it. Oh, we said when you see the word neutralize means equal sign. So that's our equal sign. That's right there, the equal sign, guys. That means every other set of numbers goes on the other side. It says 20 milliliters. Let's use a little yellow here. 20 milliliters of a 1 molar. Again, these numbers will go together on the other side. 20 milliliters is my volume of the base. And it says 1 molar, that is my molarity of the base. Now, going back here, oh, I'm sorry, wrong thing to use there. How many hydroxide ions are here now? That's right, there are 2 of them. So we must multiply this side now by 2. So 2 times 4 is 8. 8x. 8x on the left equals 2 times 20 is 40 times 1 is still 40. Divide them both by 8. So 40 divided by 8. X equals 5 milliliters. All right, that's it. Do my PDF sheet. I sign right after this as well. I'll send out the answer key as well. That's it. Bye-bye.